Hey everyone, so here is the review for 11.1 to 11.3 sequences and series. This should say 11.3. Okay, so number one, write the next three terms in the following sequences. So remember, whenever you have fractions, you really want to look for a pattern on the top and a pattern on the bottom. So the pattern for the numerator is that you're literally multiplying by 2 to get from term to term. Okay, so the next three terms, if I look at this last number, if I multiply 8 by 2, I get 16. If I multiply 16 by 2, I get 32. If I multiply 32 by 2, I get 64. And then if you look for a pattern on the bottom here, we're just adding 2, right? Or they're just the odd numbers. So you have 3, 5, 7, 9. So the next one will be 11, 13, and 15. All right? Okay, for part B, kind of if you look at this one, it's not arithmetic because you're not adding the same number. It's not geometric because you're not multiplying the same number. So on this one, you kind of have to think outside the box a little bit. Think of the one special one that we learned, Fibonacci. Remember, if you add 3 plus 5, you get 8, right? If you add 5 plus 8, you get 13. So that's what this is, adding the two terms before to get the term after. So how am I going to get the next three terms? So I'm going to get 13 plus 21. That's going to give me 34. Then I'm going to add 21 plus 34. That's going to give me 55. And then if I add 34 plus 55, that's going to give me 89. Is that correct? I hope so. Okay. So don't forget about Fibonacci. If you're having a really hard time figuring out a pattern, it's probably the Fibonacci sequence. All right, number 2, find the 25th term in the arithmetic sequence. Now, you guys, on these, we really want you using the formulas. We don't want to see like a whole bunch of numbers written out up to number 25, right? Because what if we gave you like the 1000th term? You would never have time to do that. So you want to look for some keywords on this one. First, I see arithmetic. So I know two formulas for arithmetic. I know the A sub n formula, and then I know the S sub n formula. Now look, this one you're only going to use if it says find the sum. It's not asking me to find the sum, so I'm not going to use this one. So I'm going to use the other one, which is the nth term formula, or the general formula, which is A sub 1 plus n minus 1 times d. Okay, now plugging everything in, let's see what we've got here. All right, I know I'm looking for the 25th term, so that is my n. So when I replace this little n here, I'm going to get a sub 25 equals, the a sub 1 is just the first term. Here's the first term of your sequence, so it's 7 plus your n again. We already found that was 25, so 25 minus 1. And then D, that is your common difference. That is what you're adding or subtracting to get from term to term. And if you notice on this one, you're just adding 3 over and over and over again. So your common difference is going to be 3. Now it's just a matter of figuring out what this is. So this is 7 plus 25 minus 1 is 24. And then multiply that little guy by 3. So it's going to be 7 plus 72, which is 79. Okay? All right, let's look at number 3. Okay, find the 5th term in the geometric sequence, 243, 81, 27. Now, you guys, on this one, again, look for those keywords, right? I've got geometric sequence. If it's geometric, I actually know 3 formulas for this one. I know the A sub n formula. I know the S sub n formula, and then I know the S sub infinity formula. But again, you guys, you're only going to use the S formulas, the sum formulas, if you see the word sum. I don't see the word sum, so we're not going to be using those. So the A sub n formula for a geometric sequence is A sub 1 times r to the n minus 1. Okay, now look, you might be thinking, well, I'm only looking for the 5th term, right? That means I've only got 2 more terms to go. Yeah, for a problem like this, I would probably just figure out logically, but let me show you how to do it both ways, just in case you get stuck, okay? All right, so what I need to figure out what the pattern is here. How am I getting from term to term? That is going to be my R. How do I get from here to here? Because it's geometric, I have to be multiplying by something. Now look, if it doesn't come straight to your head and you're like, I I have no idea how to do this. Circle any of the two terms. It doesn't matter which. I'm going to highlight them so you can see it. I'm going to highlight the smaller ones. So highlight two terms right next to each other, and then their ratio is going to be just the term on the right, which is 27, divided by the term on the left, which is 81. This would also work if you chose the first two terms, but they're just so big, I don't want to work with them. Now look, 9 goes into both of these guys. So 9 goes into 27 3 times, 9 goes into 81 9 times. Oh my gosh, that reduces by 1/3. My ratio is 1/3, okay? So using the formula, and then we'll use logic, and we'll kind of see how it works. So I need to find the fifth term, which means that my n equals 5. So plugging that into here, I'm going to get a sub 5 equals a sub 1 is again my first term, which is this 243. The common ratio is 1/3. And then that's getting raised to the n minus 1. Remember, your n was 5, so 5 minus 1, which is going to be 4. Okay? If we keep going, this is going to give us 243 times 1/3 to the 4th. Now, look, I know we're letting you use calculators, but I'm just a big advocate of help your calculator out as much as possible so you don't mess up inputting it in. So I'm going to raise both of these guys to the 4th power. So what I'm going to be left with here is 243 times 1 to the 4th is 1, 3 to the 4th is 81. And this is literally just asking me, what is 243 divided by 81? Which is a nice little 3. Okay, so the fifth term here should be a 3. So let's use some logic and see if that's actually true. So I'm literally going from term to term. I'm multiplying by 1/3. You guys, multiplying by 1/3 is exactly the same as dividing by 3. So look, 27 divided by 3 is 9. 9 divided by 3 is 3. We got the same answer, so we're good. Okay, and again, like, if it's that short, if it's asking for the fifth term or the sixth term or even the seventh term, go ahead and do that. Just use logic. But if it's anything bigger than that, if it's like a 12 or a 15th term or even a 50th term, you need to know how to use this little formula here. Okay? All right, find the sum of the first 6 terms of the following geometric series. So again, look for that key word. I see geometric series. I also see the word sum. Okay, so let's see what our two sum formulas are. I have a S sub n and I have a S sub infinity. This is the infinite one. So if there's a finite number of terms, which it is, I just want the sum of the first 6, I'm going to be using the S sub n. If it's infinite, I'm going to be using the S sub infinity. This time I have a finite number of terms, so I'm just going to use S sub n. Okay, so let's look at this. The formula for S sub n for a geometric series is a sub 1 times 1 minus r to the n all over 1 minus r. Okay, so let's see what we can plug in just off the bat here. My n is the number of terms I'm adding up, so I want the first 6. That means my n is 6, so I'm going to have s sub 6 equals. My a sub 1 is the first term, which is 81, times 1 minus, and then kind of come to a grinding halt here. What is the r? Okay, so look at my series. I have an 81, I have a 54, I have a 36, and then it just keeps on going. I don't have any more terms. What do I multiply by to get from term to term? Honestly, you guys, by looking at this, I have no idea. So again, you want to use that cool little trick. Circle or highlight any two terms right next to each other. I like to go for the smaller ones because it's easier to work with. And then your common ratio is just going to be the one on the right, which is 36, divided by the one on the left. They have to be right next to each other for you to be able to do that. Okay, now let's reduce this. We know 9 goes into both of them. 9 times 4 is 36, and 9 times 6 is 54, and that reduces a little bit more to 2/3. So my common ratio is a 2/3. So here I'm going to go ahead and replace this r with a 2/3. So I have 1 minus 2/3, and that's getting raised to the n power. The n was 6. All over 1 minus 2/3. Now again, let's see if I can help my calculator out a little bit. So I have 81 times 1 minus 2 to the 6th power. Let's see, 2 to the 5th is 32. That means 2 to the 6th is 64. Right? And 3 to the 6th power, it's beyond me. Let's use our little calculator. I should really know that. It's kind of embarrassing. 3 to the 6th is 729. Never mind, I would never know that. So 729. And this is all over. And you guys, 1 minus 2/3 is just 1/3, right? Now look, I'm going to help my calculator a little bit more. If I'm dividing by 1/3, what am I really doing? I'm multiplying by 3, right? Dividing by a fraction is the same as multiplying by 3. So look, I can get rid of, yikes, what do I do with my colors? I can get rid of this and just multiply this by 3. So 3 times 81, this guy right here, is 243. And then it's times 1 minus 64 over 729. Now let's see if my calculator can handle this. So I'm going to plug that in just the way I see it. 243 times 1 minus 64 divided by 729. Okay, so it gives me a crazy little decimal. Let's see if it'll change it to a fraction for me. Remember, to change to a fraction, you hit math, enter, enter. Yep, and it sure did. So you guys, this came out to be 665 all over 3. Okay? All right, now let's look at number 5. Let's look for those keywords again, right? So it says find the sum of the infinite geometric series, and sum is another keyword. So look, this time we're looking for the S sub infinity formula, which you will be using in Calculus BC one day, so make sure you guys learn this one, is A sub 1 over 1 minus R. I love this little guy, but remember, it only works if the ratio is between -1 and 1. If it's bigger than 1, less than -1, can't use it. Okay, it's just going to go to infinity. So what's your A sub 1? Your A sub 1 is your first term, which is your 81, all over 1 minus, and again, coming to that screeching halt, I don't know how to get from term to term. So look, let's look at some easy ones, right? Like how about the 9 and the 3? They're two little numbers right next to each other. So I circle the one on the right, so the ratio is going to be 3 divided by the one on the left. 3 divided by 9 is a nice little 1/3. So my ratio is 1/3, and look, that is between -1 and 1, so I'm good to go, right? So 1 minus 1/3, and you guys, look, you really don't need a calculator for this. If you do, that's kind of sad. 81 divided by 1 minus 1/3 is 2/3. And then if I'm dividing by a fraction, I'm really multiplying by the reciprocal. So this is really 81 times 3/2. And then I'm going to run out of room, so I'm going to erase this ratio, so if that's okay. Sorry about that. Okay, what is 81 times 3? That's 243 all over 2. Okay? And you guys, really, like when you're doing the homework, try to do as much of this without a calculator just to keep your brain working. I know we're giving it to you on the test, but you should really try. Okay, write the following in expanded form and find the sum. Now look, on this one, I need to see some work, okay? You can't just plug this into your calculator and go, ooh, I'm so good at that. I need to see the work, all right? So first, what is expanded form, okay? Expanded form is what numbers am I adding together? I don't need to see a lot. Show me like the first 3 and we're good, all right? So look, how do I get the first term? The first term I get is when I plug in n equals 1. So if n equals 1, I get, here, I'm going to do it over here. If n equals 1, I'm going to get 3 times 1 plus 2. Well, that's going to equal 5, okay? This little sigma, okay, that means to add. So I'm going to go plus, okay? When n equals 2, I'm going to get 3 times 2 plus 2. That's 6 plus 2, which is 8. And then plus, and let's maybe do one more. If you get n equals 3, I'm going to get 3 times 3 plus 2, which is 9 plus 2, which is 11. And then look, I'm going to do plus little dot, dot, dot. Now, if this number went to infinity, I would be done. But it's not infinity. It's a finite sequence. It goes to 100. So let's find the 100th term. That's going to be 3 times 100 plus 2, which is 302. And that is the expanded form, okay? So give us like at least a couple terms in the beginning. If it has the last one, give us the last one. Okay, now I also have to do something else. It says find the sum. Now, you guys, the tricky thing about this one is it did not tell us if it's geometric or arithmetic, right? So I have to figure it out on my own. How do I do that? Well, if it's geometric, that means I'm multiplying to get from term to term. If it's arithmetic, that means I'm adding or subtracting to get from term to term. In this case, I'm adding a 3 because I'm adding to get from term to term. That means this guy is arithmetic. Okay, so I'm going to be using the arithmetic sum because I want to find the sum. So the arithmetic sum formula states that the sum of the first n terms is n over 2, so the number of terms divided by 2, times the first term plus the last term. That is not an A. Sorry about that. Okay, so look, what am I looking for? I'm looking for the sum of the first 100 terms. It's going from 1 to 100, so the first 100 terms. So that means S sub 100, the sum of the first 100 terms. Replace the n with 100, 100 divided by 2. My first term is 5, and then my last term is 302. And you guys, look, there's a reason why we wanted you to write in an expanded form. So you had all the information just to plug it in, right? So 100 times 2 is 50. 302 plus 5 is 307. And then if you multiply those together, just give me 1 second. 50 times 307. Okay, that is 1,000. Oh, right here. 1,500. I'm sorry, 15,350. Don't know my numbers. That's really sad. Okay. All right. Now let's look at number 7. You guys, again, on this one, it says write in expanded form. Give me the first couple terms. Okay. So if I plug in n equals 1, let's do this one. If I plug in n equals 1, I'm going to get 12 times 2/3 to the first power. Okay. So you guys, this really just equals 12 times 2/3. Which is 24 over 3, which just equals 8, okay? So my first term here is going to be 8. And again, because this is a sigma, that means to add up. So I'm going to go plus. Now, let's find another one. How about when n equals 2? So when n equals 2, I'm going to have 12 times 2/3 to the second power. So this is really 12 times 4 over 9, okay? Not so pretty this time. This is going to be 48 over 9, and 3 goes into both of those, so it's going to be 16 times 3 is 48, and 3 times 3 is 9, so this is 16 over 3. Now, honestly, with this one, kind of getting tired of doing these because it's kind of hard. This one was not so bad. Getting these terms, I could do 3. I'm just going to do 2 on this one, but I am going to go plus dot, 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 plus, what's the last term going to be? Well, the last term is when n equals 5, and we may need that one, so let's figure it out. So if n equals 5, we're going to get 12 times 2/3 to the 5th power. I think that's going to get a little bit big, but let's see what we get. So this is 12 times 2 to the 5th is 32. 3 to the 5th is, hang on a second, 3 to the 5th. Okay, that's 243. Okay, and then if I multiply the 12 and the 32, okay, it's going to give me 384. So this is 384 over 243. Well, that's a nice little number. So I have 384 over 243. So again, you guys, if it starts getting that ugly, just give us like the first couple and we're good with that, okay? All right, now I'm not done yet. I just did the expanded form, but they also want me to find the sum. So is this geometric? Or is this arithmetic? Now, you guys, just by looking at the form, if I have a number raised to the n power, that is my common ratio. So because this thing has a common ratio, it's geometric. So because it's geometric, I'm going to be using the geometric finite sum formula, okay? And for this one, it's S sub n equals A sub 1 times 1 plus r to the n over 1 plus r. Yikes. No, it's 1 minus r to the n over 1. I'm using the wrong formula. Sorry about that. 1 minus r to the n over 1 minus r. Okay? Now, plugging everything in. Okay, so how many terms am I looking for? I'm going from 1 to 5, so that's 5 terms, right? If you count on your fingers, 1, 2, 3, 4, 5, that's 5 terms. So I want S sub 5 equals A sub 1. That's my first term, which is the 8. Times 1 minus the common ratio. You guys, we found that right here. The common ratio is 2/3, so it's 2/3 to the n, which is 5, all over 1 minus 2/3. And again, let's help our calculator out a little bit. So this is 8 times 1 minus, we already did this 2/3 to the 5th power right here, right? So that's 32 over 243. and then divided by, and this guy 1 minus 2/3 is 1/3. And remember, if you're dividing by 1/3, you're really just multiplying by 3. So let's multiply that by 3. So then what are we going to get? We get that this is going to be 24 times 1 minus 32 over 243. Now let's help us out here with the calculator. If I plug that in, 24 times 1 minus 32 divided by 243. And you guys, it should give you kind of a gross little fraction, and it does. And then let me try to change it to a fraction here. Math, enter, enter. Okay, this one came out to be 1688 over 81. I'll put it over here, 1688 all over 81. Okay, that was kind of gross. All right, let's look at number 8. Okay, so when I look at this one, it still wants a sum in the first couple terms, right? So let's write up some of the first terms here. Here, I'll do the work up here so I have a little bit more room. So when n equals 1, if I plug in n equals 1, I'm going to get 24 times 3/4 to the first power, which is just 3/4, right? 4 goes into 24 6 times. 6 times 3 is 18. So that first term here is 18. Oh my gosh, I'm having issues. Let's write equals. Okay, again, the sigma means to add up, so I'm going to have a plus. If I have n equals 2, okay, I have 24 times 3 over 4 squared. So that's really 24 times 9 over 16. And then you guys, if I reduce this, let's see, 2, I think it's just 2, 12, no, 4. 4 goes into 24 6 times, 4 goes into 16 4 times. So 9 times 6, that's 54. I could have done even something bigger than that, right? 8, oh my gosh. So it's 54 over 4. If I divide that by 2, I'm going to get, what is that, 27 over 2, okay? So again, I'm getting kind of sick of this. This is just like the numbers are just too big. So let's just dot, dot, dot this. But you guys, look, at this time, my dot, dot, dots are just going to keep on going. Dot, dot, dot. It's because this thing is going to infinity. Now, look, that's really good news. Because if I am going to infinity, the only formula that I know that goes to infinity is the geometric formula S sub infinity equals a sub 1 over 1 minus r. Now, let's see if I know all the information. Do I know a sub 1? Yep, here it is. So that's 18 all over 1 minus, what's the common ratio? Remember, it's anything that's being raised to the n power, so it's 1 minus 3/4. Now again, let's see if we can help our calculator out. So this is 18, 1 minus 3/4 is 1/4, and if I'm dividing by a fraction, that's the same as multiplying by the reciprocal. So then if you do 18 times 4, you should get, oh my gosh, I should know this. I think it's 72. Yes, 18 times 4, that's just going to be 72. Okay? All right, and then last one. So when I look at this one, you guys, I've got an issue here. This is not going to be arithmetic or geometric. I can already see it. Look, if I look at them separately, this 3n minus 1, that's an arithmetic equation. It's linear. It's in the form y equals mx plus b. But this n squared is not, okay? That's not arithmetic or geometric. So the only option I have here is to write out all the terms and add them together. Now, luckily, there's not very many terms here. So let's just go ahead and do it. So look, if n equals 1, so replace all your n's with 1. You're going to get 1 squared over 3 times 1 minus 1. So it's going to give me 1 over 2. So my first term is 1 over 2. Again, your sigma means to add up. Now let's plug in n equals 2. If I plug in n equals 2, I'm going to get 2 squared over 3 times 2 minus 1, which gives me 4 over 5. So this is plus 4 over 5. Okay, got to do it again. If n equals 3, I'm going to get 3 squared over 3 times 3 minus 1. So that's 9 over, let's see, 8 plus 9 over 8. And then last but not least, I'm going to end at 4. So if n equals 4, I'm going to plug that into it. So I get 4 squared over 3 times 4 minus 1, which gives me 16 over 13. So that's plus 16 over 13. Now look, that is the expanded form. I'm kind of done here, right? So all I really have to do is now add these fractions up. And you guys, before, they had to do it by hand. You guys are so lucky. You can just plug it into your calculator. So go 1 over 2 plus 4 over 5 plus 9 over 8 plus 16 over 13. And you guys, that gives me a weird decimal. Hit math, enter, enter. And on this one, I got 1901. 1901 all over 520. That is going to be your sum. Okay, getting close. All right, let's look at number 10. This one says put into sigma notation. You guys remember sigma is just this little symbol, right? That means to add up. So let's go ahead and get our boundaries established here. So I'm going to do a little sigma. Hey, if you want to make your life easy, start at n equals 1. If you want to make it hard, start somewhere else, but it's going to be kind of harder, okay? Now look, how many terms do I have? I have 1, 2, 3, 4, 5. So I'm going from n equals 1 to n equals 5. So that's the first step. Now I need to find a formula for these numbers so that when I plug in n equals 1, it's going to spit out 5. When I plug in n equals 2, it's going to spit out 11, and so on and so forth. So look, let's determine, is it geometric or is it arithmetic? How am I getting from term to term? Well, if you look at it, it looks like we keep adding 6 to get from term to term. So if you're adding, I know that this thing is going to be arithmetic. Okay, now look, I'm looking for the general term. I'm looking for a sub n. So my formula is a sub 1 plus n minus 1 times d. So let's plug it in. So I'm going to get a sub n. Remember, I don't want to replace my n's because I want to be able to plug them in, right? A sub 1 is the first term, which is 5, plus n minus 1. The common difference is the 6. And then all you do is you kind of simplify it. So you get 5 plus, if I distribute that, 6n minus 6. If I combine the 5 and the negative 6, I'm going to get 6n minus 1. And then just plug that in here. Now look, test your theory out. Make sure it actually works. How about if we pick like n equals 4? It better spit out 23. Well, look, 6 times 4 is 24. 24 minus 1 is 23. If you pick a random number like that and it works, chances are you got the right one. So there is sigma notation. All right, let's try number 11. Okay, number 11. So again, I'm going to start with sigma. N equals 1, 2. Well, where does it end? Whenever you see this dot, 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 that means you're going to infinity. And you guys, the only thing we know about infinity is we know it's geometric, but let's double check that. Let's make sure this thing actually is geometric. Let's see if it has a common ratio. If I'm looking at this, right, I'm literally multiplying by 1/3 to get to 27. I'm multiplying by 1/3 to get to 9. I'm multiplying by 1/3 to get to 3. So this common ratio, because it's 1/3, this is definitely a geometric series, okay? So what's the formula for a geometric series? It's a sub n equals a sub 1 times r to the n minus 1. And again, I want to plug in everything except what has n's I want to keep. So a sub n equals, my first term is 81. My common ratio, again, we said was 1/3, and then to the n minus 1. So this is going to be 80 times 1/3 to the n minus 1. Okay? All right, let's look at fractions. Okay, again, let's set up our sigma. Make your life easy. Start at n equals 1. I have 1, 2, 3, 4, 5 terms, so I'm going to end at 5. Now, whenever you have fractions, you guys make sure that you're looking at the top separately from the bottom. So what kind of a pattern do you see there? Well, I'm not adding 3, and I'm not multiplying by 4, so I'm kind of stuck. You guys, if you notice, 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared. Okay, that's just a square formula. So the top part is just going to be n squared, okay? Over, now let's look at the other set here, okay? 1, 3, 5, 7, 9. These are just the odd numbers. And remember from your notes, you guys, please remember this. Even numbers are just 2n, And the odd numbers, if you're starting at 1, would be 2n minus 1, okay? So because these are just the odd numbers, it's just going to be over 2n minus 1. So the more of those on that first notes that we ever gave you on this unit where you said must know this, if you know those, it's really going to help you with these. All right, let's look at number 13. Find the general term a sub n for 4, negative 9, 14, negative 19. So what I like to do with these is I kind of like to pretend those positive and negatives are not there for a second. So look, I have 4, 9, 14, and 19. I'm just going to pretend them away for 1 second. Is this arithmetic or geometric? Okay, well, let's look. I'm adding 5. Okay, it looks like I'm adding 5. Because I'm adding 5, that means this thing is going to be arithmetic. And the arithmetic formula for a sub n, again, is a sub 1 plus n minus 1 times d. Okay, so let's replace everything but the stuff that has an n, so I can plug the n in. So a sub 1 is my first term, so that's 4, plus n minus 1 times the common difference, which was whatever we added, which was 5, right? Okay, if I go ahead and distribute the 5, I'm going to get 4 plus, distribute that 5, 5n minus 5, and then 4 minus 5 is negative 1, so a sub n is going to be 5n minus 1. Okay, so look, so far my formula looks like this. A sub n equals 5n minus 1. But sadly, it's not right because this formula spits out only positive numbers. I want the first number to be positive, the second to be negative, then positive and negative, and then keep on going. So look, memorize these two things. If you want them to flip-flop from positive to negative, you want to multiply everything by negative 1 to the n minus 1. You can also do negative 1 to the n plus 1. That works as well. If you want it to go from negative, positive, you want to multiply everything by negative 1 to the n. So what have I got here? I got plus, minus, which means I've got this one. So I'm going to multiply all of this by negative 1 to the n minus 1. Okay, so look, this right here, let me highlight it. This 5n minus 1 is going to give you these numbers. The negative 1 to the n minus 1 is going to cause them to flip-flop. All right, it's a really good one to know that's on your test. Okay, find the next 3 terms in the recursive sequence. Okay, so this one, remember the main thing on here, remember how we were talking, let's say you have like a sub 1, a sub 2. These are just like the first term, second term, third term, etc. And then we get to some random term a sub n. Okay, remember the next term would be a sub n plus 1. The next term would be a sub n plus 2. And so on and so forth. So that's the important thing that we're learning here. So it says find the next 3 terms. So let's write down what terms they already gave us. They told us that the first term is 2. They told us that the second term is 3. Okay, and I just need to find the next 3 terms. So I need to find a sub 3, I need to find a sub 4, and I need to find a sub 5 using the little formula for they gave me, right? Okay, so look. It's saying, and you can use a formula for this if you want to. Okay, so they're saying a sub n plus 2. Okay, so that's like this guy right here. Okay, equals 2 times a sub n plus 1. So this equals 2 times the term before it, and then plus the term before that. Okay, so if I want to find the next term, if I want to find a sub 3, so basically what I'm going to be looking for, I'm going to use that pattern to look here. Look, if I want to find a sub 3, that's basically going to be 2 times a sub 2. So it's 2 times a sub 2, which is 3, and then plus a sub n, so plus the term before that, so plus this guy, which is a sub 1, and a sub 1 was 2. Okay, so what does that give me? 6 plus 2 is going to give me a nice little 8. So a sub 3 is going to equal 8. Okay, you guys, I'm actually going to write it over here a little bit better. A sub 1 is 2, a sub 2 is 3, a sub 3 is 8, and then I need to find like 2 more because I wanted the next 3, right? Okay, so how do I find the next one? So if I'm looking for this term right here, it's going to be, so this is my a sub 4 right here. Again, if I look at the formula, it's going to be 2 times the term before, so it's 2 times 8, and then plus the term before that, which is 3. So that's 16 plus 3, which is going to give me 19. Okay, and then if I want to find the last one, so that's going to give me my a sub 5 right here. So it's 2 times the term before that, so it's 2 times 19, and then plus the term before that, which is 8. So 2 times 19, that's 38. 38 plus 8 is 46. Okay, so the next 3 terms, the answer to this would be 8, 19, 46. It's kind of funky. Okay, find the sum of the first 9 terms of the geometric sequence. Okay, so you guys, I think this one's awful, but it's okay. We've got this. Okay, let's look at for the keywords again. Geometric, sum, first 9. Okay, so is this finite or infinite? It's definitely finite, right? Because it says just the first 9 terms. So I want to use this awful little formula, S sub n equals a sub 1 times 1 minus r to the n all over 1 minus r. Okay, so what's the first term? This one's really gross. The first term is -2, so I'm going to have -2 times 1 minus. Now, what the heck is this common ratio? So you guys, what do I have to multiply -2 by to get 1/2? What do you guys think? -2 times what equals 1/2? Well, the one thing I do know about it, it has to be a negative number because I want a negative times a negative to be positive. How about if we multiply by 1/4, right? That gives me 2/4, which is 1/2. So my common ratio here is going to be a -1/4. So when I plug that into here, I'm going to have -1/4 to the n. What's my n? I want the first 9 terms, so this is 9, all over 1 minus, and then the common ratio is -1/4. Now, you guys, be really super careful with this one. Okay, let me simplify this, help my calculator out a little bit. I have -2 times 1 minus. I cannot combine these two together yet because I want to raise this -1/4 to the 9th power first. Okay, so -1 to the 9th power. Let's see, I know 1 to the 9th is 1. 4 to the 9th is a lovely, holy cow. So this is going to be -1 over 26,2144. Let's hope there's not something like this on your test. And then all over, now look, these two can be combined together. 1 plus 1/4 is 1 1/4 or just 5/4, right? Okay, now look, if I'm dividing by 5/4, what are you really doing? You're just multiplying by the reciprocal, so times 4/5. Okay, so what do we get now? Okay, 4/5 times -2, that's -8/5. And then here I have 1 plus 1 over 262144. So at this point, I was able to go ahead and combine those because the other number's not getting raised to a power anymore. And you guys, look, I don't think the calculator is going to be able to handle this, but let's try it. So I have -8 divided by 5, and then parentheses 1 plus 1 over 262144. Okay, really gross decimal. Let's see if it can turn it into a fraction for me. No, it won't. So you guys, I'm just going to go approximately -1.6. Okay, so I just plugged into my calculator. It just didn't come out pretty, so you can go ahead and leave it. Okay. All right, almost done. Find the sum of the arithmetic series 6, 13, 20, 27, and 97. Again, look for those keywords. I have sum, I have arithmetic, okay? And because this actually ends, it has a first term and a last term, I know it's finite. So I'm going to be using S sub n equals n over 2 times a sub 1 plus a sub n. All right, so let's plug it in. I want the sum of the arithmetic series. Now, you guys, I don't know how many numbers there are here because I don't know how many numbers there are in between here. Okay, so let's see if we could just figure it out. Plug in what we know. I know S sub n equals n over 2. I don't know what the n is. The first term is 6. The last term is 97. okay? So all I really need is that n. How many terms does it have? Well, if you don't know, go to the other formula. The other arithmetic formula is a sub n equals a sub 1 plus n minus 1 times d. You guys, look, I don't know what n is, so I should try to find it, okay? So this right here is the last term, which is 97. This right here is the first term, which is 6. N I don't know. And the common difference, well, how am I getting from term to term? It looks like I'm adding 7. So if I solve this, I'm going to get 97 equals 6 plus, distribute this guy, I'm going to get 7n minus 7. So that's going to give me 97 equals 6 minus 7 is negative 1 plus 7n. If I add 1 to both sides, I'm going to get 98 equals 7n. And then if I divide by 7, that's going to give me n equals 1 with a remainder of 2, so it's going to be n equals 14. So now that I know that n equals 14, I can just plug this in here. So it's going to give me 14 divided by 2, which is 7. 97 plus 6 is 103. So then if I multiply 103 times 7, I'm going to get 721. Okay, so you guys, this one's kind of a two-step problem. Look, if you're plugging stuff into a formula and you're missing something, go to the other formula to try to find it, okay? All right, let's look at 17, almost done. An auditorium has 20 rows of seats, okay? There are 15 seats in the first row, so row 1 has 15 seats. There are 16 seats in the second row, so row 2 has 16 seats. Row 3 has 17 seats, and so on and so forth, all up till we get up to row number 20. So I'm going to do a little dot, 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 and we're going to get into row number 20, which I do not know. How many seats are there in the auditorium? Okay, so look, is it asking you how many seats are there in row 20? No, it's asking you how many seats are there in the entire auditorium. So I want to add all these little dudes up. Does that make sense? Okay, so now I'm going to use the sum formula, but is this arithmetic or is this geometric? Okay, well, look, how am I getting from term to term? I'm adding 1. So this is arithmetic. So I'm going to use the arithmetic sum formula. So it's going to be S sub n equals n over 2 times a sub 1 plus a sub n. Okay, so let's plug this in. So that's going to equal n, which is the number of rows, which is 20. So I have 20 over 2. A sub 1, there's 15 rows in the first one, right? 15 seats in the first row, sorry. And then a sub n is the very last one. That's this guy right here that I do not know. How do I find out what the last row is? Again, if you're missing something, go to your other formula. Your other formula is a sub n equals a sub 1 plus n minus 1 times d. I would really like to find out what the 20th term is. So look, a sub 20 is a sub 1, which is 15, plus 20 minus 1 times the common difference. The common difference was just 1 on this one. Remember, we were adding 1. So this is really going to just be 15 plus 19, which is 34. So if I put in a 34 in here, 20 divided by 2 is 10. 15 plus 34 is 49, and 49 times 10 is 490. Okay, number 18. A side of an equilateral triangle is 20 inches, okay? So you guys, let's draw this out a little bit bigger. So what does equilateral mean? Equilateral means that all the sides are exactly the same. So this is 20, this is 20, this is 20. And then it says the midpoints of the sides are joined to form another inscribed equilateral triangle. So basically, if you take the midpoint, and the midpoint, it's going to form another equilateral triangle. And on this one, it says if the process is continued without end, find the sum of the perimeters of the triangles, okay? So you guys, look, if I cut those guys in half, right? Instead of now being sides 20, the sides are now going to be 10, 10, 10, okay? If I do it again, here, let's do a different color, maybe like yellow. If I take the midpoints again, Okay, again, I'm cutting those in half again. Now it's going to be 5, 5, 5. Okay, so everything keeps getting cut in half, cut in half, cut in half. Okay, now let's see what the question is. The process is continued without end. That means we're going to what? Infinity. Find the sum of the perimeters of the triangles. So look, I'm looking for the S sub infinity formula, which is A sub 1 over 1 minus R. But look, I don't really even have a sequence here. So let's see if we can come up with a sequence that actually gives me some of these numbers. Okay, so what's the perimeter of the blue triangle? So look, perimeter just means to add up the sides. So the perimeter of the blue triangle is 20 plus 20 plus 20, which is 60. Okay, then plus. What's the perimeter of the red triangle? That's 10 plus 10 plus 10, which is 30. Then plus. What's the perimeter of the yellow triangle? That's 5 plus 5 plus 5, which is 15. And then you guys, it keeps going on forever and ever and ever. Okay, now try to see if you can find a pattern here and plug stuff in. So A sub 1 is your first term, which is 60, all over 1 minus the common ratio. What am I multiplying by to get from 60 to 30? Just multiplying by 1/2, right? 60 divided by 2 is 30. 30 divided by 2 is 15. So I'm multiplying these guys by 1/2. So my common ratio is just 1/2. Okay, and then if I go ahead and do that, it's 60 over 1 minus 1/2 is 1/2. And you guys, if I divide by a fraction, I'm really just multiplying by the reciprocal. Look, I didn't even need a calculator. We're too smart for that, right? So it should be 120. Okay, now number 19. Now you guys, for 19A, we need to see work on this. If you just plug it into your calculator and give me an answer, that's not going to be good enough. And we need to see what you're doing to make sure that you can work with factorials. And you may ask, why, Ms. Cruzy? Why? Well, it's because when you get into Calc BC, you have to do this without a calculator. Sorry to burst your bubble there. Okay, so what we do here is we're going to find the biggest factorial that we can. That's this guy. So find the biggest factorial on the top, find the biggest factorial on the bottom, and now let's reduce those guys. So 11 factorial is 11 times 10 times 9. Now, once I hit the one that's the same as on the bottom, I'm going to stop, and then I'm going to go over 9 factorial. Is that all right? Now, let's look at the other two. Okay, I'm going to highlight in a different color here. Now, who's bigger this time? Okay, the bigger factorial's on the bottom, and then this other one's on the top. That's that 7 factorial. So start with the bigger factorial on the bottom and start breaking that down. So 8 factorial is 8 times 7. Now I'm going to stop once I hit this guy and go 7 factorial. And here it's still a 7 factorial. Okay, now look what cancels out. The 9 factorial cancels out with 9 factorial. 7 factorial cancels out with 7 factorial. And what do I have on the top? I have 11 times 10 all over 8. Let's try to reduce this a little bit. You guys, 2 goes into both of these. 2 goes into 8 4 times. 2 goes into 10 5 times. So this is going to end up being 55 over 4. Okay? All right, same thing with letter B. Let's start with the bigger factorial. So the bigger factorial is 2n minus 2. The reason why is because -2, right, is bigger than -4, right? When you're subtracting 2, that's bigger than if you're subtracting 4. So I'm going to start with 2n minus 2, and that's the one that I'm going to start breaking down. So 2n minus 2 factorial is 2n minus 2 times... Right, now subtract 1, you're going to get 2n minus 3 times, subtract 1 more, you're going to get 2n minus 4. Now look, why am I going to stop here and put a factorial on it? Because there's a 2n minus factorial on the top that if I stop, it will cancel out. Now here, I'm going to cancel these guys out. What's left over? Well, there's a 1 on top, and there's a 2n minus 2 times a 2n minus 3 on the bottom. Okie dokie. All right, so there's review 1. Hope you guys enjoy that. I know that was a long video. Have a good day, guys.